Yeah.
Oh, you are?
That makes sense.
Disconnect.
Yeah. I can always do like this.
Yeah. Looking to work in
Straight into I feel like this is a code, it's just pretty. It's gonna be more something.
Oh, okay. Okay, that's fine too.
Yeah.
Okay, yeah, we can do that. Because I thought you had your own presentation.
I did. I'm not sure. I didn't know like how much you're using.
Okay, I'll talk.
Yeah, okay. And I was just like, you're flexible based on.
East side, or at least like foreseeable future. Right now, 27. I do anything like markets, so market research, community.
Is that what I do?
So it's just like originally I only did. This is let's see what's that.
I don't wanna go.
3 to 5.
Getting sense of.
Real estate finance. Are you happy to take my class? Are you taking 366? 366.
Last year. Right now,
Let's wait for 2 more minutes.
100,000.
No, I'm probably just familiar face. Yeah. What's your name? Angel.
We're
Are you in real estate finance?
companies,
How you like it?
which are now
Pretty nice. Are you CSBA?
and they bring in the titles.
You're like into finance, definitely. But mostly real estate. What do you like? What do you like? Like
It's a lot less. It's really good.
yeah.
Shares.
Also like
Investors and their own teams.
but I'm saying like with that, like would you be interested in finance?
It's like a
Tax
free.
form.
Honestly, for me, I think either
investing,
develop like software development, and then after 5 years.
Never joined.
5 years.
Yeah, I did.
Or start my own. Now I would have went real estate finance.
Okay, let's get started, folks. Folks, let's get started.
Honestly.
So today the class will be split into 2 different sections. Okay, the first one will be regular lecture. Also, I extended the deadline for homework 1 because I realized you needed today's lecture to actually finish it. And secondly, so after the lecture, we're gonna have Alex, our guest speaker. So he's from Shima Capital. He's gonna basically present, basically talk about his perspectives on the space, and it'll be, it'll basically complement what we learned today. So we got someone that's really deep in the industry and also from the investment business side of things to complement our technical talks, all right? So today, so last time we talked about, we wrapped up how Ethereum worked. We talked about how Ethereum had 2 different types of accounts and the 4 different attributes in an Ethereum account. Now, who can tell me what are the 2 types of Ethereum accounts?
Yeah, EOAs, externally owned email accounts and smart contracts.
What's the main difference?
The EOAs have no script or data because the decisions are made by a human.
What does it have that the smart contract account doesn't have?
Private key.
Yes, that's fact. Yeah. Yeah, so EOAs are owned by humans. Their origins are basically private keys, whereas for smart contract accounts, there's no private key, so by default, they're not owned by anyone. Their address is derived from a hash of the combination of the deployer's address and the account nonce of the deployer. Now, speaking of nonce, what does an account nonce do in Ethereum?
Make sure that they're used to correct the mistake. If you send too much on accident, it's a counter that makes sure that you're not double spending.
How does correcting the mistake work?
So you can change your nonce back to the number it was before. For example, if your nonce was 0 and you send a transaction, if you want to send for 2 on accident, you could, it hasn't been processed yet, you can pay a higher gas fee to get something with 0 cents for the same nonce. And that makes sense.
Yeah, that's the key, right? So it must be unprocessed when you're trying to do that, okay? But if it's already mined, included into a block, then you can't do that. All right, good. And also, what's gas? Who remembers?
How much computation a transaction is going to take?
Yeah, so how are transaction fees or gas fees calculated on Ethereum?
Is it based on how much weight?
It's an equation, some math operation, something else.
Oh, I think it's gas. It's gas time. Plus gas use in the gas price.
Gas use and what?
In the gas price.
What's the math operation there?
Multiplication.
Yes, that's correct. Gas used times gas price. Right now, Adrian, you got it mixed up a bit. So
You got my name mixed up too.
yeah, did I?
Angel.
Angel, my
Close.
I'm sorry.
No, you're good.
I'm really bad at this. So okay. So what's the difference between gas limit and gas used? You can tell me. Maybe from this side of the room. Not you, because you already answered.
Gas limits the most amount that the users are willing to spend.
Yeah.
And the gas price will actually.
Or gas use, gas price, right? How is gas price determined?
Demand, supply, demand.
Can you elaborate that?
Basically, if the network is busy, the gas price will be higher.
Why?
Because there's not enough space in the blocks for all the transactions to be processed. The miners are going to be the ones with the highest gas prices.
That's right. So the capacity of the network is more or less fixed at any given moment. But now when you have more people trying to use it, then and also because miners they always pick the transactions with the highest gas fees to process. So it becomes a bidding war between all the users trying to get there. Like if you're really urgent, you want to get this transaction through right away, then you have to be one of the highest bidders, and that drives up the transaction fees. And this is also why in the bear market, when everyone says crypto is dead for the 800th time, gas fee transaction fees are so low because everyone thinks it's dead and no one's using it. All the hype has faded. There's not a lot of activity on the network. Okay. Yeah, so that roughly covers what we talked about last time. Yeah, and today we're gonna kind of go into Ethereum a bit more. We're gonna talk about smart contracts and what the heck is EVM, what are DApps, and Web3 in general. All right. So first, let's talk about smart contracts. Okay. So who remembers this guy, Nick Szabo? Who remembers this name? Sounds familiar to anyone? Yeah.
Is he the one who like first coined smart contracts?
Yeah, so he was involved in the early days of blockchain. Pearl Chaz will be very sad that no one remembers his name.
Is he one of the people that claim to be sufficient?
I don't think he claimed to be, but he's one of the suspects. And other suspects, including Craig Wright. No, okay, so his definition is that it's a set of promises specified in digital form, including protocols within which the parties perform on the other promises. So basically, basically programs that execute predefined logic. So promises that can't be broken, right? And also, I just want to say that in the context of blockchains, because normally when you say contracts, you think of, okay, I mean, the closest thing like your apartment lease, right? That's a contract you have to sign, right? You have to run your credit score and you have to sign your life away, right? So that's some kind of contract. And most contracts that we come across in the real world has legal implications, right? But on the blockchain, the word contract doesn't have any legal meaning, okay? Smart contracts is more or less just a fancy word for a program that's deployed onto the blockchain, that runs on the blockchain, right? So basically, yeah, software programs that live and run on the blockchain. That's what smart contracts are, okay? So there are three main properties of smart contracts, okay? First is immutable. Now this just kind of, and all three, they carry over from the properties of blockchain, right? So first is it's immutable. It cannot be changed after deployment. Oh, and this kind of leads me back to Tuesday and last week's content. So in an account, we have 4 attributes, right? So we've got balance, we've got nonce, we've got contract code, we've got contract storage. Now here it says, or I say, smart contracts cannot be changed post deployment. But we talked about, so I want someone to tell me what's the difference between contract code and contract storage.
Like contract code is the actual the actual code of it, like the solidity, and the storage is like what's in the variables.
Right, that's partially correct, yes.
I was gonna say the storage is the data and the contract is the process, like the thing that needs to happen.
Right, the contract code stores the logic. And the contract storage stores the variables, right? If we have them declared. So when I say smart contracts cannot be changed post deployment, what I really mean is that smart contracts logic cannot be changed post deployment. But if in your logic you've implemented something that can save some outside information, then of course every time when someone tries to save something to the contract, it's going to stick. Otherwise, it's not saving, right? So when I talk about contracts being immutable, it's more about the logic, like you can't change it, which is also why, smart contracts, this is why people say when you use smart contracts, you don't have to trust anyone because the logic is there, and if the deployer, if they verify the source code, then you can see what's happening, and they can't really change it when you go and use it. So you don't have to trust anyone. You just have to trust like what you see with the code, and that's actually what you're going to get forever. And now, of course, some of you, if you've heard of upgradable contracts, it works a bit differently, but it doesn't break the property of smart contracts being immutable. But it's a more complicated thing that we'll talk about later. I saw a hand somewhere.
Yeah, sorry, I just wanted to ask, are these slides on the catalog?
I haven't posted this one, I don't think.
Oh, okay.
Yeah. Should I post it now?
Yeah.
Okay, I'll upload it. Okay, I'll post it right now.
Thank you.
Uh-oh. I'm not gonna let you see my computer.
Private keys?
Huh?
You got the private keys on there?
I've got many interesting files on my computer. Okay, I got it. It should be, wait, why is it 3? It should be 2, I can't. Okay, it's up there now. Sorry about that. Okay, let's go back. Okay, so we talked about how smart contracts are immutable. Second, smart contracts are deterministic, right? So it's just like, because smart contracts are programs, and programs fundamentally you can think of them as math equations, right? So if 1 + 1 equals, so 1 + 1 equals 2, I just said it, and does everyone agree that 1 + 1 equals 2? Does anyone not agree 1 + 1 equals 2? Nobody, good. Then let me ask you a really hard question. 24 hours from now, what is 1 + 1? Right, it's 2, right? Because the input is the same, it's 1 and 1, and the output's always 2, because it's deterministic, right? So that's just like computer programs and just like smart contracts, right? The outcome is the same given the same input, all right? Now this exclude the now you can think you can say then what about random numbers, right? Because in a computer system, you know, you can have random numbers, but so this is more computer science now, but there isn't a truly random number generator. It's always pseudo-random, and especially on the blockchain, you know, it's actually difficult to get a truly a pseudo-random number. The best you can do is you can do something based on timestamps, so seconds since January 1st, 1970. But again, that's like predictable because we know how time works, right? So Chainlink, actually, I'm not shilling anything, but Chainlink, they're one of the few projects that actually provide a solution that gives you a verifiable random VRF. I forgot what F stands for, but they're basically able to supply you like with a random number. But even that random number is generated from something, all right? And if all the inputs, including what it's generating from, stays the same, then the output will be the same, even if it's a random number, because again, nothing is really random, right? Because we live in a simulation. All right, so smart contracts are deterministic, okay? Now, thirdly, they're resource limited. Now, this goes back to what we talked about when we talked about gas limits, right? So each block and each transaction, they both have their own gas limit. So basically that, and gas represents, again, the amount of computation or storage that you perform with that single action. So really, when there's a limit on that, basically means smart contracts are resource limited, right? So you can't execute something indefinitely, right? The gas limit actually caps the execution steps. And if you exceed that cap, everything gets reverted. Because remember, on the blockchain, things happen atomically, meaning that either everything happens or nothing happens at all, right? There's no like halfway. I can't transfer you 10 Bitcoin halfway, like it can't fail halfway. You either have it or you don't, right? So smart contracts and everything's the same thing. Either everything happens or nothing happens, okay? If there's a failure in the middle, and they don't, and you know, I mean, developers they can handle errors, they can purposefully make it so that things are able to fail halfway, but by default, if you run into a problem, everything gets reverted back to the original state, okay? So these are the 3 main properties of smart contracts, all right? Any questions on this part?
Yeah, you said like gas works similarly in terms of incentives as the Bitcoin block size, where it creates like scarcity. Or did I hear that wrong?
I don't think so, no. Yeah. Which aspect of gas are you referring to? And what scarcity are you talking about?
Well, like the fact that you have to like pay for gas, and that there's like a cap to like how much gas or weight can be put into like one transaction of Ethereum, which is similar to how Bitcoin has a block size limit.
Oh yeah, you can, they're similar. I believe Ethereum also has a block size limit. Yeah, so you can't just so there used to be an attack where they were able to spam a very cheap, well, like in Solidity, we just have Solidity code, but really it goes down, when it goes down to like the more low level code, they're called opcodes. So basically computer code that they're not meant for humans. If you have CS, it's basically assembly, okay? So someone found out a way to use the opcode, where the opcode is actually cheap, but then they're able to write a whole bunch of garbage data to the blockchain at a very cheap cost, and they were like spamming the Ethereum blockchain that way. And they actually fixed it. It was just like a few years back. But yeah, but they also do have a cap on the block size, I believe, not just gas. Yeah, okay. So life cycles of a smart contract. Okay, so basically the steps, what it takes for something to go from an idea and then to your fingers on the keyboard to the computer and then eventually onto the blockchain, right? So first, it's written in Solidity by us developers, right? You'll all be future developers by the end of the semester, okay? And then after we write the program, it's compiled to EVM bytecode by the compiler. Now, what is bytecode? I have a link here. I'm not sure what it does because I made this last semester, but I believe it's to demonstrate what bytecode is. Oh, yes. So let's take a look here. All right. This is our good old Ether scan. Okay. So here, so I'm looking at this smart contract. What is this? I don't know what this is. So, okay, so Decentraland. Why does it only have 3 transactions? That's weird. Anyhow, so this is Decentraland. This is like one of the metaverses on Ethereum. This is one of their contracts. I suspect it's been abandoned because there's like nothing happening. But you see, so up here, this is the Solidity source code. All right, and if I zoom in, you can see that it's half English, right? Even if you don't understand programming, you understand the individual words, right? You know what a string is, you know what a contract is, you know what asset registry storage, you know what that roughly means, right? You know what is a name, what's a symbol, what's a description. So you know what they mean here. This is the this is the Solidity code, all right? But down here we've got the byte code, which is well, this is nice, right? I mean, and by the end of the class, you'll be able to see, this is like the Matrix, you know? If you've seen the movie, just look at this crap and then they're like, oh, Smith? You know, that's what Morpheus did in the second thing, whereas they're just looking at random code. But this is bytecode. By the end of the class, you'll be able to be just like Morpheus. No, you won't. No one can ever understand what this is, okay? This is not meant for humans. This is meant for computers to read. And guess what? This is, again, in hexadecimal, all right? So, and then actually, it's a hexadecimal representation, but really, it boils down to binary and whatnot. But basically, this is bytecode, okay? Your program up here written in nice English, all right? In more or less plain English, but you know, in Solidity, it's compiled. By compiled, I mean it's built, it's transformed into this, so that computers can work with it, all right? Because computers don't know English. They only know, the only language they know really, now we're not talking about quantum computers, okay? Just regular conventional computers. All they know is I either have electricity passing through or I don't. So that's 0 or 1, okay? They only understand zeros or ones. So binary, all right? So whatever we write gets turned into EVM bytecode by the compiler, okay? Now, EVM stands for Ethereum Virtual Machine. Basically, it's an execution environment for that gibberish bytecode that we saw, okay? And for different execution environments, like there's EVM, so Solidity turns into EVM. There's also, if you guys have heard of the language Java, it's very polarizing. Some people love it, others hate it. So Java runs on the JVM, Java Virtual Machine, all right? And the bytecode will be different. They won't understand each other's bytecode, all right? It's like different languages within the computer space, okay? It's like one computer speaking French, the other speaking German, they don't understand each other. Okay, so same thing with bytecode. All right, and after that, that bytecode will be deployed to the blockchain with a transaction, okay? So it's a contract creation transaction. It's a special kind of transaction. All right, because the to address I believe the to address is actually 0 or something. So it's different from your regular transactions or interactions, right? But the blockchain software sees this and it knows that you're trying to deploy a new contract. This is actually one of the contracts I deployed. I do not know what it was. I don't remember what this is, honestly. But yeah. All right. So smart contracts are again owned by no one and used by everyone. Okay. And by owned by no one, I mean that they don't have private keys. So no one can really control them. Now, again, we're going to talk about adding ownership to the contracts later on, but it's a different kind of ownership, right? They don't have private keys. The contract creator has 0 control by default. Okay, if you don't have any control mechanisms built into the contract, you're not gonna. Once a contract deploys, you can't do anything with it. I mean, you can use it, but you can't like randomly erase things or whatever, right? You can't do that. And unless you've added restrictions into the logic, everyone can interact with the contract. Okay. Oh, now this is the question I think I have in homework 1. So deletion is possible, okay, but it has to be coded into the contract in the first place, right? So there's an opcode called self-destruct, all right? It kind of erases the contract from the current state of the network, and refunds gas because you free up more storage in the future. But as I alluded to on Tuesday, nothing truly gets deleted on Ethereum on the blockchain, right? Because if you look into the past, before this thing self-destructed and it'll still be there. It's like time travel, right? And you don't have to worry too much about it. You'll probably never use self-destruct. There are better ways to deal with like shutting down or disabling a smart contract, right? Okay, so we've got some, and also feel free to stop me anytime if you have any questions. Okay, I'm sorry. So popular smart contract languages. Oh yeah, you had a question?
Yeah, who's paying for the gas? No one knows, is it just the users?
The deployer. Okay, so when you're deploying, the deployer pays for it because it's a regular transaction, right? So you see this deployment transaction. This is my address. I'm sending it, and then when the users use a smart contract, they pay for the transaction fees. So this is why. So this is different, and this is also one of the barriers of entry to crypto is that like when you log on to Facebook, your data gets sold to whoever, but you don't have to pay for anything. Imagine in a world where you have to pay for every single Facebook post. You like someone, suppose okay, you got to pay for it, and obviously people don't want to do that. But you know, in a decentralized world, that's what happens because like you are responsible for your own actions, basically, right? But the upside is that you know exactly what's happening. But on Facebook, for platforms like Facebook, like I just talked to a friend about some product on the phone or something, and the next thing I know, Instagram is giving me this ad that exactly like it's almost like they know exactly what I need or something, right? Yeah, but anyhow, so basically on blockchains, the users pay for the transactions. Now there are services out there. In fact, at each time we actually prepay our users' transactions. There is a way to do it. Basically, you're able to have the users create a transaction, sign it, but they don't have to be the ones broadcasting it. Okay, you send it to one of our relayers, and we execute like the on-chaining action, and basically we're able to pay the transaction fee for the users in that way. It's still a valid transaction from them because they created it, they digitally signed it. It's just that the person who's performing the on-chain action is different. It's controlled by us, and then we'll pay the fees, not the users. So that's one way to do it.
So then how are you monetizing? How are you monetizing?
The current signing okay, this is like turning into okay. So the current signing product that we have, we don't plan to charge any fees on it ever. We have future products down the line that are more institutional, and we charge like a service fee, certain percentage. Yeah. Thanks. That's a show. Yeah.
Does it mean that you guys can also blacklist accounts from making signatures?
No, not really. I mean, we can choose to not pay gas fees for a certain address, if they're like spamming the heck out of our service. But no one's bored enough to do that first. And secondly, our smart contract actually doesn't have a blacklist feature built in, unlike USDC, which is they've already started using. So and I don't think like our product is not interesting enough for people to spam it, because it's just signing documents. What is there to hack or spam, right? It's not like DeFi or some other things where there's money involved and you're like, oh, like this person's kind of money launderer or whatever, you gotta blacklist that person. Like we don't have that problem. So for us, we don't really, but definitely, that again goes back to, everyone can interact with it, but if you have like a restriction built in, a certain mechanism built in, like if you can basically check where who's the sender or the caller, like where is it coming from, and you can get the address, and if the address matches one of the entries on your blacklist, you can just revert the transaction or something. Yeah. All right. Any other questions about the rough process of how smart contracts go from here to here? No. All right, let's move on. Okay. Popular smart contract languages. All right. First one is LLL. Just know from the name that it's not a fun language. Okay. It's the first high-level language. Honestly, I do not know what the heck LLL is. I have never seen it. I don't know how to write it. I don't know how to read it. But basically, it's actually a very low language. It's a very old language. And Lisp, it's another programming language that's old. And if you go to school at UCI, they force you to learn it. But it's rarely used. Basically, nowadays you make a post on r/ethdev or something and asking help in LLL, no one knows what the heck you're talking about. Okay, it's very low level, meaning that so low level versus high level language. It's kind of like, okay, who here plays video games? Who here games on PC? Oh, nice. Okay. Who here has built their own PC? All right. Okay. So high level language and low level language, it's like buying a pre-built PC or building one on your own or something, right? So basically higher level languages, they're easier to write. Okay. But the things that you can do, they're more limited compared to low level languages, where you can really optimize the details if you want to. When you build your own PCs, you can, for example, the RAM, you can go for like DDR5, like the, whatever, 4,000, 5,000, 6,000, CL8, 32, 48, whatever, right? But if you don't know what the heck you're doing when you're doing your own custom water cooling, and if you don't know what I'm talking about, it's totally fine. And if you have a leak somewhere, or when you're overclocking, you mess up the voltage, you can just burn your whole computer, right? So lower level languages, they have less protection in place, but that gives you more flexibility to really, squeeze every bit of performance out of it. But again, it's not safe, right? You have to know what you're doing. Okay, so LLL is a very low level language, right? It gives developers the power to aggressively optimize. But then, you have to be careful. You have to really know what you're doing, okay? And then we have Solidity, okay? It's kind of like a mix between C and JavaScript. It's the most popular by far, and I'll show you how far in a bit, okay? And then we also have Viper. So Solidity is made by, I think, Gavin Wood or some other people, I think. And then Viper is actually led by Vitalik Buterin, like the Russian guy that become the face of Ethereum. I think it's funny how whenever you say Ethereum, no one really thinks of Gavin Wood. They just think of Vitalik Buterin, And if you actually go to some of the ETH conferences, just for example, in February this year, I went to ETH Denver. Vitalik was actually there. He was actually in some kind of weird costume. And I kid you not, the line to get into the venue that he is in was like 2 blocks long. I just gave up like immediately. I knew it's not worth it. Like you stand like, unless you have some kind of VIP pass. I think Mike, did you try to sneak in? Did you sneak in?
Yeah.
Oh, yeah, okay, there we go. Yeah, Mike is the master of sneaking into places without a ticket, okay? But basically, yeah, he was there, he was, talking about things, looking at people's projects, judging. And he's become, this spokesperson for Ethereum, right? Whatever he says, it's a big deal whenever he tweets, even if it's in like half broken Chinese, asking people to like tea or coffee. He writes blog posts him on Ethereum Foundation, but you don't really see Gavin Wood doing a whole lot of that, right?
Also, wasn't Nick Sabo also one of the early guys?
I think he died. No, okay,
No.
I think he's like way before that,
Yes.
He was like-
it was Bitcoin
like
community.
before Bitcoin, right?
Yeah.
Yeah, oh, maybe he didn't die, I'm sorry.
I don't
But
think
he was like he was one of the OGs of blockchain, right? Not just any blockchain, right? So now we have Viper, all right? It aims to be more secure and auditable than Solidity. I don't know what that means, honestly. But apparently it's better at doing math than Solidity, which is why Uniswap V1 and Curve Finance are actually written in Viper. But it really tells you something when Uniswap V2 and V3 ditched Viper and went to Solidity. So the problem is, honestly, like everyone here that's taking this class, learning Solidity, even if you don't know how to program, by the time you finish, you're already more scarce than the majority, like 99% of the CS majors out there, okay? Because no one really knows how this language works, right? And of course, you have me at the top of the hill, right? Of course. But Solidity is already niche enough, and Viper has an even smaller community, which means if you thought it was difficult finding good Solidity tutorials online, good luck trying to find anything on Viper, right? The official documentation isn't even completely complete for Viper, all right? And also it handles math better than Solidity only in older versions of Solidity. The newer versions of Solidity actually fix the problems that they were trying to fix, which means that Viper right now, not a lot of people are using it, okay? All right. So Solidity, Gavin Wood, lots of community support tools. You've got a lot of pre-built contract modules ready to use, and we'll talk about it in the future with OpenZep and stuff, all right? So you've got lots of resources comparatively. But for Viper, it's actually newer than Solidity, but it is actually not Turing complete, okay? So that's interesting. It lacks features, it lacks community support because no one's using it really. It aims to be more readable, but I looked through it and I don't agree, okay? I don't completely agree, but again, I'm biased because I don't know how Viper works. So on GitHub, which is all of your new favorite website, okay, for this semester, there are around 5,000. So I did the search January of this year, okay. Is Move a Solidity language? But oh, right, Move. I totally forgot Move. I didn't look into it. I'm not sure, but I haven't heard of it.
It's the Facebook.
Huh?
Facebook is like
Move. Okay, then it's definitely not popular. I'm actually don't know. I'm actually not sure. Move. Someone can look it up. But basically, I think a good way to gauge the popularity is just by looking for the number of source files on GitHub. Okay. For Viper, there are 5,000. Solidity is 4 million. So that's the magnitude of like the difference in popularity between the two languages. And Move, I'm not sure. Someone can look it up. All right. Solidity versus Viper. Okay. So this is something that just kind of prints out or saves hello world to the contract. All right, to this smart contract. Someone say something. No. And so basically these two are doing the same thing. Okay, we got Solidity on top and Viper at the bottom. I suspect so for those of you who knows how to program Python, then this one will look a lot more familiar to you, right? And the reason why I think I don't like Viper that much is because I hate Python. So I'm very biased in that way. But this is basically how different they look, more or less in terms of source code, right? Okay, any questions on all the language stuff that we talked about? Just a high level overview of the different languages that we no questions. All right. So now let's move on to the Ethereum virtual machine, okay, we briefly talked about what it was. It's like an execution environment, right? So it's a runtime that facilitates smart contract execution, okay? It runs on every single Ethereum full node, all right? So remember how when we talked about the block structure last time, the anatomy of a block, right? We've got a bunch of different Merkle roots in there. So, or roots in there, and then basically they represent the different trees. We got the role state tree, transactions tree, and receipt tree, okay? So for each transaction, the way that the Ethereum virtual machine works, processing transactions or smart contract interactions, in our case, right? So for each transaction, the role state is used as a starting point, okay? So if you remember, we went over the state transition slides. We had the original state on the left, transaction in the middle, and then the new state on the right. If you remember the graphics here, right, from last time. So at the very beginning, on the original state, it will be the role state, okay, and then the EVM will then process the transaction, okay, and then it will actually generate a receipt, which is the post-transaction state, okay. And the reason why we call Ethereum the world computer is that all instances in all the nodes, they form a consensus and agrees on a single state per block, okay? This is also why it is slow, because really everyone's not only doing their own thing, but they not only doing more or less the same thing, but they have to agree with each other, okay? It's not like every single node is doing its own stuff in parallel. That would be super fast. It's like a huge, that is actually a worldwide supercomputer. But Ethereum, decentralized systems, because we need consensus, because we need everyone to agree on everything. So, you know, it's a lot slower. Everyone's doing the same thing and then they try to agree with each other, roughly, okay? Because again, you know, everyone, as transactions propagate at different rates, you know, some people get it first, some people get it second and whatnot. So it's going to be slightly different, but, you know, everyone tries to form a consensus. Okay, so, oh, that was short. So any questions on Ethereum virtual machine? You don't have to know how it works really, because to do that, you know, we got to get down to the assembly stuff, which we definitely, like, you don't have to know solidity, EVM assembly to write smart contracts. Like that's like if you're trying to squeeze every single last bit of gas from the contract, like trying to really optimize it. And sometimes we use EVM assembly, but you don't have to. Okay. Any questions on anything so far? Okay, perfect. No questions. So now let's talk about decentralized applications versus regular applications. Okay. I'm sure everyone here has used an application, right? My USC, that's an application. All right, Google Gmail, that's an application. So any application usually consists of two parts. Okay, there's the front end side and the back end side. Okay, so the front end side is basically what's presented to your computer. The back end side is the parts that you don't see, that does the processing and everything. And sometimes they're not on your computer, they're on their own servers. Okay. So for web apps, it's the front end. One example of the front end for web apps is like the website that you see, okay? For mobile apps, it's the apps that you install, okay? And regarding the back end, it's basically a server that's most likely belongs to either Google or Amazon or Microsoft, right? So they basically handle any logic that the front end doesn't. For example, when you're buying your, I don't know, McDonald's, what's your favorite fast food restaurant? I don't know, McDonald's, Wendy's, right? Wendy's because you're really nice on Twitter, right? They have some fun Twitter comments. Anyhow, let's say you're going to Wendy's with your credit card, okay? And obviously your credit card balance isn't stored on your credit card. Otherwise, what's stopping you from, you know, just buying some chip reader and chip programmer to just reprogramming your balance all the time, right? So your credit card really only contains some identifying information about you, okay? And then it actually gets sent to Visa and then the bank to actually see if you still have any credit left, and if you do, then okay, then they're gonna deduct this part from your available credit. Okay, so now Visa and the bank, they're the back end. okay? The chip reader thing, that is the front end that you're interacting with, when you're swiping or tapping or whatever. Okay, so front end is the thing that you see, back end is the thing that I don't see. And things like, you know, updating your bank balance, they can't be done on the chip reader because it's too easy to be compromised, which is why it's done on the back end in some server farm or whatever that they own, okay? And usually the back end, you know, honestly, 4 years of CS, okay, and maybe 1 year of 1 or 2 years of master's. So 4 years of undergrad CS, 2 years of master's degree graduate school, and then you get hired to Google, and all you do is CRUD, right? So honestly, that's like 90% of the CS work out there, just to demystify everything. And when you look at it, it's really not that hard. It's basically taking data in, and obviously like building a nice front end for people to interact with, and then taking data in. You either create things in a database, you read things from a database, you update things in a database, or you delete things from the database. That's literally 9% of CS majors crunching away in FANG companies doing this, okay? It's really not that holy or anything. But you know, but these are really basic things. But again, there are a lot of ways to do this. There are a lot of ways to optimize. So you know, again, it has its own nuance. But you know, this is basically what most people do when they're programming, right? So any questions on the difference between the front end and the back end? All right, let's move on. So DApp versus app, or DApp, whatever, however you want to call it. So for the regular application, so by that I mean our Web 2.0 applications, meaning basically every single thing that we use, all right, today, from your EV charging station to your real news on Facebook, you know, or anything, right? Or you know, or when you buy some Samsung or LG TV, you spend $2,000 on a TV and there's freaking ads on it, right? So that's your front end, right? It's usually centrally hosted. So the web apps, even the front end, they have to be hosted somewhere so that everyone can access them, right? And the back end are also centrally hosted, right? They're, you know, AWS, which is Amazon Web Services, Microsoft Azure or Google Cloud Services, Google Cloud Platform, whatever, right? And front end and back end, they're usually, okay, well, they're not hosted together usually. I'm not sure, it depends on the company. But point is, regular applications that we use today, Web 2.0 applications, they're usually always centrally hosted, right? Which is also why a couple of years ago, when AWS had an outage, half of the websites in the US just died, right? Also why when Facebook had an outage, when even their own techs were locked out of their own server rooms, they can't fix a problem. Instagram was entirely down, you can't do anything. That's because everything's centrally hosted. So, you know, it's like it's not actually, blockchain is, okay, what is a hive mind? Maybe I'm mixing definitions, but anyway, but for traditional stuff, you know, if the brain dies, then the body dies, right? Everything else dies because it's all coming from here, okay? But a Web3 application, a decentralized application, the decision making and the hosting, whatever, ideally it's spread out, okay? The front end sometimes is hosted on IPFS. So IPFS is like it's called interplanetary file system. It's like a file hosting platform that's decentralized. Think of okay, who here has, let's be real here, who here has torrented anything? There we go, very honest. So it's kind of like a torrent network, but for storing files and retrieving files. Okay, that is, I just described the torrent network. Anyhow, that's kind of what IPFS is, okay? We actually, in our company, we tried it, but it wasn't the availability wasn't very good, actually. So it was okay in North America and Europe, but in Asia or, you know, South America, Africa, it's actually like people can't really, like they have issues trying to access our website. So we actually eventually we started hosting the front end on AWS again because they've got solid servers all over the world. All right. Well, that's a compromise. You want people to be able to use it. You got to compromise on some of your morals, or not morals, but you know, your principles. But the important thing is, so the front end actually doesn't matter because usually the front end is just a way a good UI in order to get you to interact with the smart contract, right? The important stuff still happens on the smart contract, and that is still on the blockchain. And there's no choice, like it's just on the blockchain. Otherwise, it's not a smart contract, it's not a decentralized application, right? So, what really matters is actually, like, regardless of where the front end is hosted, what really matters happens on the blockchain. Okay, so the backend lives on the blockchain. There's no server. Okay, so there's no central server, but people run their Ethereum nodes on AWS sometimes when it's profitable. But it's still, again, there's also people running it with their own server, with their own mining farms or whatever. So the smart contract, there's no central point of failure. So if AWS, if they fail, if they go down, then you've still got, okay, there used to be Chinese miners, not so much when China banned it. But you've got other miners in other parts of the world that can pick up the slack, more or less, right? So the database that we talked about here in decentralized stuff, it's actually the Ethereum's world state tree. So that's like a huge decentralized distributed database. Okay, not distributed yet, just decentralized. When data sharding comes around, they will be distributed, more or less. Okay. Any questions on this? Yeah.
I have two. So a good way to go, would a good analogy for like when you're talking about like the credit card versus the bank for like DApps, would it be like for like a DApp, would a front end be like an NFT website where you print it and then the back end would be like Ethereum? Would
Yes.
that be correct?
Yes, just like how you can mint NFTs and buy NFTs, buy an ape on OpenSea. Even if OpenSea gets hacked or whatever, your NFTs they're safe on the blockchain.
So that'd be like a front end.
Yeah, so the OpenSea is the front end. The NFT, the actual smart contract, is the back end. And also, you don't need OpenSeas to view your BFP or whatever, your NFT's metadata. It's just that OpenSeas, it takes the data from the blockchain, processes it, and then makes it like, it creates like an easy to use UI around it. Basically, sugar coating the raw data, but at the end of the day, they come from the same place, which is the blockchain. Yeah.
Oh, and then could you explain what you meant by it's decentralized but not distributed yet? Like,
Okay, so for distributed, distributed meaning that, so my kind of definition when I talk about distributed when it comes to database stuff is that you store one part of the database here and the other part there, and then with this request, they kind of talk to each other to figure out who has which part and whatnot. But currently Ethereum, everyone stores the exact same copy of the blockchain. So everyone has the exact same copy of the database. But in the future, with Ethereum sharding, it will basically chop up the blockchain into smaller parts and give it to different people. So you might have a part that I don't have, but when you put us together, we have everything. So that's what I meant by currently it's not distributed, but in future it will be.
okay.
Yeah. All right. Any other questions? All right, let's go on, move on to the next one. Oh, wow, I forgot I have some graphics. So on the left side, you have a traditional web application, okay? So we talked about, you've got the front end, which is the web page, you got the back end, which is like the server stuff, and then you also, they separated the database from the back end. But I categorize them into like one whole thing, okay? But for a decentralized application, you've got the same front end. The main difference is that the entirety of the backend lives on Ethereum. Okay, that's the logic plus the storage. Okay, and actually, this is another good way to think about contract code and contract storage. You can think of this as contract code. So this is just a backend server that has a bunch of logic in order basically saying how to process incoming information or how to respond to requests. But then the actual data is saved separately into like a database. Okay, so and then for smart contracts, you've got the contract code with the logic and contract storage with the actual data that's being stored. Okay, so that's like another way to look at things. Right? Any questions on this graphic? Right? Yeah.
Yeah, do you ever see like a blend of like both using the blockchain, also like traditional databases, and like say OpenSea, they like have some internal metadata as well? Like say they like wanna feature like some like project, where do they store that data?
Oh yeah, that's on their own, yeah, so you know, it doesn't have to be, just like the world, you know, this doesn't have to be black and white. So there's a lot of hybrid approaches like OpenSea, you know. For, you know, they can like, let's say they have like featured projects on their front page, or they have their own database to store like what's featured. Like, but I think the principle, at least my principle when it comes to building Web3 products, is that whatever you store on centralized databases cannot be crucial to the function of the product. Like, it should only be there for convenience, right? So let's say I'm running OpenSea and my servers get blown up or something. Then sure, you lose the featured thing, but then, you know, NFTs are still there because they're fundamentally on the blockchain, right? But I can't store your NFTs on my, then it wouldn't be NFTs anymore, right? And if my server gets blown up, your property is also gone with it, then it's not really it's not a Web3 application. Okay. At least that's how I define it. All right, any other questions? All right. Okay, Web3 versus Web2. Okay, difference between Web3 and Web2 is that they added 1 to the number. Okay, and also if you look up Web3 on Google, you actually get something really different. So especially Geeks for Geeks, which is of course the go-to site for any CS major. So this is the textbook definition of Web3 versus Web2. Okay, and this has been here before blockchain existed, I think. So Web 1.0, we can all agree. So that was mostly even before or around when we were born. Okay, and now exposing my age here. So it's a read-only web where you can visit people's web pages, but you can't interact with them. It's very company focused, so like you don't get to have your own website back in the 1990s, right? There's like a lot of forms, directories and whatnot, and banner advertising, like the strip that you see on older websites and whatnot, vertical or horizontal, the really old ones, you see them. And they're usually just like plain HTML, which meaning that like they look super basic. They look really basic. They look basic. They don't have a lot of content. They're usually owned by some company or some professors from school, whatever. And also, you can't interact with them. And in fact, the internet actually was it was initially like a military / academic project that got started, right? So it actually trickled down to us normal peasants from the military, and I think actually UCLA, I forgot what the other school is, and I think USC was actually one of the earlier participants of building out the internet infrastructure. All right. Okay, so that was Web 1.0. Okay, back when everyone had dial-up connections. Okay, and now and even nowadays, if you use Spectrum, you probably still get dial-up speeds. Anyhow, and then we have Web 2.0. Okay, so this Web 2.0 now the textbook definition starts to deviate from our trendy crypto definition. Okay, so in the textbook definition, again, it's now you can read, now you can write to the web pages, right? You don't have to just read it. You can actually interact with it, right? And it's basically a lot of blogs, Wikipedia, that kind of stuff. So imagine internet, basically the internet before Twitch and streaming became mainstream. That was Web 2.0 back then, right? Basically, not a lot of content creation, not a lot of mobile websites. You have to use this thing called the Internet Explorer, if you know what that is, right? So that's Web 2.0, basically to share content, but you don't create content, right? And Web 3.0, the Web 3.0 in the textbook definition is basically our current creator economy, which when did being a YouTuber really start to blow up? Was it like 2010? I think maybe, yeah. Right, so from 2010, people, playing, streaming gaming on YouTube, to nowadays people streaming themselves in the bathtub on Twitch, not getting banned, right? So that's a Web 3.0 creators economy. according to the textbook. Okay. Basically, user-generated content, it's getting so the content generation is being decentralized because now anyone can become a YouTuber, right? Including I'm putting these lectures on YouTube for people to look at. All they're unlisted, so I can qualify as a YouTuber maybe. So anyone, if they set their mind to it, there's like TikTok, right? Which is like which is half addiction, half spyware, as they say, right? You also have Instagram. Remember when Facebook and Instagram, the feeds? Remember when they used to be chronological? Wasn't that nice? Like you know exactly what you missed, because now they switched it up so that you have to keep scrolling. You don't know if you've seen everything yet, right? But I remember back when I was in high school when everything was so chronological. But again, nowadays, my point is anyone can become a TikTok star or YouTube star, whatever, as long as you work hard enough and you have and you're lucky, you're blessed by the algorithm, right? So this is what Web3 is by textbook definition. Okay, but I thought Web3 was about blockchains, yeah. No and yes. Okay, so there are multiple definitions. Okay, by textbook definition, we are already deep in Web3, but by our crypto trendy definition, we're deep in Web 2. Okay. So by our popular definition, by the crypto definition, Web 2 versus Web 3, Web 2 basically an internet dominated by companies that provide services in exchange for personal data. Hint, hint, Cambridge Analytica, does that name ring a bell? Facebook, Zuck, spoke these meats. Okay, maybe not that one. So that's Web 2, right? Your data getting sold. And I find it hilarious when websites, like after California passed the Consumer Data Privacy Protection Act or something, you know how websites usually ask you to accept cookies? There's accept and deny. Now there's accept and do not sell my data. It's like, okay, I didn't know you were selling my data to begin with. Okay. And Web3 is an internet dominated by decentralized applications that allow anyone to participate without monetizing their personal data. And by that, I really mean like the data that you, like it's very, basically in Web3, it's very transparent where your data goes, basically. And your data, like, because in Web3, your identity, it's basically your Ethereum address, if we're talking about Ethereum, right? It's your address. And let's say I look at Mike's address, mikema.eth. It's funny, I actually have the private key to that. But if I look at if you guys look up mikema.eth on Etherscan, while someone's actually doing it right now. But if you do that, whatever you see on there, all the data that you see on Etherscan, they're all you can see about Mike. And Mike knows exactly what's up there because he made those transactions. So he put these data out there for everyone else to look at. Maybe not willingly, but that's how the blockchain works. Everything's public. But the point is, nothing hidden will ever make its way onto the blockchain without the sender's explicit consent. Yeah.
So say in the future where a lot of people start getting these personalized addresses where if your name's in it,
yeah,
you can find someone's email, attached to it, things like that. And companies start doing the same thing. And companies also have their addresses with their names and things like that.
Yeah.
Can't then a third party come and build an algorithm that kind of looks at individual profiles?
Yes, on-chain analytics, yes. But the point is, whatever data you do put up there, you've consented to it because you created the transaction, it's up there. If you never created the transaction, if you never agreed to it, then it cannot be up there because you never initiated it.
But then can't the same thing happen, like where, say you keep buying, I don't know, sports like jerseys.
Yeah.
And these people see that you put in your advertising, they this one sports jersey.
Yeah.
Then can't they kind of sell that data because they found it?
They can, but they don't have to sell it because it's public information anyways. Currently, the problem is, okay, maybe like packaged, yes. But currently the problem is, if I put my phone in front of the TV and switch to a Spanish channel for half a day, my Instagram ads will turn into Spanish, like Spanish stuff, which, I don't know what the F is happening, right? But that's like how it works right now, right? So I think that's like the main problem. Yeah. right? That's a good question. Any other questions?
That's a popular definition, right?
That's like the trendy crypto Web3 definition.
One can argue that since the data is public, it's actually easier to monetize for certain people.
It's easier and harder because you're like, when you're just repackaging something that's already public, it's harder for you to make that sell. But like if you're able to silently track people and only you have that data, no one else has it, only you have this, only I know what color underwear you like,
Yeah.
and no one else does, then that information, okay, maybe it doesn't actually have value, but let's just say it does.
Took the words out of my mouth.
Okay, any other questions? Okay, let's move on. All right, so this, now Web 2 versus Web 3, okay? This feels really ironic in the wake of USDC banning people. But again, that's because they built in the blacklisting controls and ownership and whatnot, okay? But if it's a truly decentralized program or whatever on Web 3, then for Twitter, they can censor any account. Web 3, you can't, right? Because control is decentralized. And it's basically, it's the same idea, right? Web 3, there's no central entity to censor anyone unless you somehow pissed off all the miners in the entire world, and they collectively decide to screw you and never process your transaction as long as they see your address. Then then that's like your problem, right? But that's a collective censorship, right? That's fine. That's democracy in a way. That's a decentralized decision making. Point is, no central authority can call the shots in the true Web3 application.
Well, the first one for Web3 isn't really true, is it? Because if you have a DApp, there's still like the front end of it that can censor.
Yeah, but then you can choose to not use the front end. Just look at it, it's all on chain.
So just like.
So the point is, they can't erase what you put on the blockchain. Yeah. The front end, yes, they can censor, but you can just build a front end that doesn't censor.
Okay.
Yeah. This is like the other argument with like child porn and Arweave, which is difficult, right? Like they can make the official software censor all known child porn, data, content, whatever. But the problem is people can just build their own client and not do it, right? Yeah, so that's like one problem. And yeah, Web2 servers, again, talking about AWS stuff going down, all the websites are dead, but Ethereum and Bitcoin, they've never had an outage besides, forking and whatnot, right? Okay, then Web3 good, Web2 bad, right? Of course, again, it's not as clear cut as we want things to be, right? So Web3 has its own problems. First of all, performance. Visa can process tens of thousands of transactions per second. Ethereum, it's like 10. Okay, it's a tiny bit of a difference, right? If we're honest about it. And user experience, it is tremendously confusing. Okay, who here remembers the first time trying to figure out what the heck is MetaMask and how to use Uniswap or anything really? How hard was it?
Very hard.
Yeah, it's confusing. There are no tutorials, and the best part is if you send the money to the wrong address, it's gone. Can't get it back. Yeah, so very confusing. Long wait times. Well, that's just for Bitcoin, but for Ethereum, if your gas is underpriced, if your transaction is underpriced, then it's going to stuck in the mempool forever, right? Accessibility. You don't have, like for Web 2, we don't actually think about it, but the reason that we have MetaMask is so that we can interact with Web 3. But what do we use to interact with Web 2? The browser, right? Everyone has a browser. We don't even think about it. But that's like the MetaMask equivalent, more or less, right? And Microsoft has had it built in since Windows 98. But we don't have MetaMask built in anything, right? And people don't even know what the heck a MetaMask is, right? So that's accessibility. And also cost, right? If something's free, then you're the product, basically just selling your data. But in Web3, you're not the product, but no one likes paying money, right? I don't like paying money to tweet something. I don't like to pay money to do any of the trivial things that I think, making it like liking a post on Instagram, we all do agree that's like a trivial thing to like a post on Instagram. But actually, when you think about it, it does involve a lot of engineering stuff. Then who's paying for it, right? How can you just use Instagram for free forever? You can't, obviously you can't. So they gotta monetize it in some way. There's no Instagram premium. There's no like, you can only see 5 posts a day unless you unlock it or something. So they're profiting from some other way, which is usually selling your data. Okay. Any questions on that? We just talked about. All right, so let's move on to tokens on Ethereum. Okay, so first let's talk about the native token. Okay. Ether is Ethereum's native token. It's mainly used to transfer value, to pay for transaction fees. Okay, these are basically the only 2 uses of Ether. Okay, it's built into the system, therefore it's native, right? Since day 1, it's there. Okay, Genesis block is there. It's the block reward that went to the first miner. Okay, but then, okay, we have custom tokens. We have fungible and non-fungible tokens. Fungible tokens are so ERC20 based. ERC20 stands for, it's like Ethereum request for comment. It's basically like a proposal for a certain standard that's being put onto the forums and then eventually processed into an official standard. But that's like proposal number 20 or something. I don't know how they name these numbers actually. But it's ERC20 based. Every token has the exact same meaning and value. 1 Doge equals 1 Doge. Although Dogecoin isn't an ERC20 token, it's its own blockchain. 1 sheep equals 1 sheep. Okay. There's also non-fungible tokens, your apes. Okay. They're ERC 721 based, so it's a different token standard, right? Yeah. My board ape costs 1,000 ETH. Yours costs 1 ETH. We're not the same. Okay. So non-fungible tokens, they're not fungible, right? And in 256, remember I think in midterms and finals, you have to write out the 7 different properties of Bitcoin. One of them being fungible. I always forget that one for some reason. Okay, and also ERC20 and 721, they're standards to implement smart contracts. So every single SHIT coin you see on Ethereum, they're smart contracts. All right, every NFT you see, including Bored Apes, they're managed by a smart contract. Okay, but Ether is built into a network. There's no smart contract involved. It's just like Bitcoin. It's a native token. Okay. What about my sheep, right? My sheep, USDT, Uni, they're all Ethereum tokens. Okay. They are not blockchains on their own. They build their smart contracts that live on Ethereum, and they conform to that ERC20 standard. Okay. Binance Coin, BNB, Solana, ADA, which is Cardano, AVAX, Avalanche, and Polkadot, they are not Ethereum tokens. Okay, they are the native tokens of their own blockchains. They have their own blockchains, not Ethereum. Okay, so that's like something that you have to know. Now, some of them, like AVAX, I think they have a version called WAVAX, so wrapped AVAX. It's basically a wrapped version of AVAX that lives on Ethereum. So the way it works is that there's a bridge, and you can send AVAX from the Avalanche network to Ethereum network, and then they give you wrapped AVAX on Ethereum. So it's like yeah.
How is it just built into Ethereum to check that they're like going by the standard, or how does that work?
So the standard is just, so let's say we had a convention where, let's say I'm going to make the following action a standard. Okay, every time, starting from next week, every time you come into the room, you have to scream out your name, otherwise it won't count your attendance. Do you have to follow it? You don't have to. Okay, you can choose not to follow it, but if you don't follow it and everyone else does, then I won't be able to count you towards attendance. So you don't have to conform to the standard. It's just that when everyone does and you don't, then people expect to let's say call a certain function, or they expect something to be there, but and it's not, then they won't be able to properly interact with whatever you just wrote. It's like, why do trains need to have a certain track width in the US, right? You can choose to not do it, but you just can't go on the US rail tracks, right?
So, or like if you were to make a token on Ethereum but not follow the ERC-20 standard, would you be seen as less trustworthy or just?
No, people just won't be able to interact it in the standard way. And when people can't interact it in the standard way, they just won't use it.
So it would be more difficult, not less
Yeah,
trustworthy.
yeah.
Gotcha.
Yeah.
Does that mean like you could change one ERC-20 standard token for another directly, like swap it, but then if one wasn't following the ERC-20 standard?
No. You can't swap it directly because they found that they have different values. It's like both British pound and US dollars, they're both paper money, but you can't just like exchange it directly. There's a market for it.
Isn't it kind of pegged to Ethereum? It's on the Ethereum
It's not
platform?
pegged to Ethereum.
Not
It's
pegged, but like, I'll think about, I don't know exactly what I want to.
that like they can interact with each other on like a programming sense because they're all on the same platform. And this is also why like exchanges like Uniswap, they don't have to rewrite the code every time a new token gets listed because they conform to the standard. They just have to make their code work with the standard, and whatever coin new token you add, as long as they conform to the standard, then they will work with Uniswap. Yeah. Okay. Any questions about this part? All right. Yeah, so what's the point of ERC-20? Why can't we just use Ether for everything, right? So ERC-20, because they are smart contracts, they allow us to implement custom logic into them, okay? Because they're not programs. They're not just just paper money anymore. They're programs. So for example, the Squid Game token, once you get it, you can't sell it, all right? That's their custom logic to rug pull you. There's also a bomb token that was run in 2018. So basically, every time you transfer a token to someone else, it burns a part of the transfer. So that's like it's like an experimental token or something. I don't know what eventually it became of it. I think I actually still have some. Or it can be programmed to represent equity, right? Company or project shares. And for equity, you can do stock splits. You can issue more. You can send it to. You can just like mint equity for certain people. That's all possible with ERC-20 because it's just a smart contract. Whatever logic you want, you can make it happen more or less because Ethereum is Turing complete, right? Governance, right? So let's say you're in this DAO or something. So one token can represent one vote or something like that, right? Or utility. Okay, so like for Chainlink, right? Your incentive to run the Chainlink node so they're like a decentralized oracle, basically provide price fees and whatnot to smart contracts. So incentive to run the node is that you get link as a reward. It's like kind of almost like a mining reward, but just a node reward for operating, right? And there's a lot more uses because again, it's just a program. The possibilities are endless as long as you don't blow the gas limit on a single transaction. Okay. Then what is the point of 721 tokens? Non-fungible tokens, NFTs, right? They can represent an asset. It could be in the metaverse. It could be a fake asset, or it can be real estate or something, right? Access could be a concert ticket, hotel keys, right? Collectible, yes. Trivial JPEG of an ape for social clout, right? Which is somehow 100 ETH. Identity, right? Avatar, national ID, or magma.eth, something like that. Or attestation, we can have our degree certificates on the blockchain. That's totally doable as an NFT issued to you, right? It's actually trivial to build. Just no one wants to do it because if everything's on the blockchain, then how can they charge you $20 every time you want to get your transcript or something, right? When do you get to make one? Well, after the midterm, actually, final homework assignments, you'll get to make these. Okay. All right. Any questions on what we talked about today? Yeah.
So wrapped ETH, so that's ERC-20 based.
Wrapped ETH is ERC-20.
And what are some of like I know we'll go into more detail about it, but like what's like the main utility?
Okay, so the reason why wrapped ETH exists is that for ERC-20, there is one functionality called approve. Basically, if I have 10 wrapped ETH, and I approve you spend, so basically you can spend however much I approve on my behalf.
Interesting.
Basically, I'm giving you permission to spend my money, but you can't do that with just native Ether. Because Ether is just like paper bills, like there's no logic in it. But for ERC-20, that's like one of the things that you can do.
Okay, and you can, okay, gotcha.
Yeah, there's like, we'll go over the standard later, you'll see all the things that it can do.
Awesome, thank you.
Is that like Ethereum's version of the Lightning Network? Cause I remember.
No,
something
so
about
Lightning Network is basically a centralized solution, well, not simple, it's more centralized than Bitcoin. It's like a transaction caching network to speed everything up, but it doesn't have any custom logic. It's just to speed, it's just by using caching and relying on the nodes being honest, like it speeds up Bitcoin transactions by not having to wait for 10 minutes.
But there is a locking factor though, right?
What factor?
A locking factor, same like as you said in Wrapped.
What do you mean locking factor?
Maybe I'm remembering incorrectly, but when you do something on the Lightning Network, you're like locking it with like a multi-sig or something like that.
Okay, so that one is more like built into the protocol and not like Wrapped ETH, which is an application. It's like two different layers. So Lightning Network is more of an augment to the Bitcoin protocol, whereas Wrapped ETH is just one of many programs written on Ethereum.
Can you expand on what you mean by like an augment?
So it's like what's a good analogy? An augment, I just mean like an enhancement that's optional. So it works with the Bitcoin protocol on the protocol level. Whereas for Ethereum, for Wrapped ETH, it's just a regular smart contract. There's nothing special about it, besides the fact that
It's just like coded in it.
yeah, it's coded in Solidity. I can show you the source code right now. It's very straightforward. Whereas, like the equivalent of Lightning Network would be, if you've heard of it, like the rollups like Optimism or Arbitrum or whatever. So
That'd be the equivalent
of Lightning on Bitcoin.
Gotcha.
Yeah. So it's its own side network that tries to offload transactions from the main network to speed things up. Whereas
does it qualify as a sidechain? Does it qualify as a sidechain?
I don't think Lightning does. I'm not sure. I don't know too much about Lightning. So, yeah. You can ask Chaz. He is a big Bitcoin Cash holder. He must know all this.
Well, I mean, he did well at like explaining it, but it's just so much information.
There's a lot of controversy around Lightning. Mainly, people just keep debating if it's really decentralized. Why are we using it?
Yeah. Because you were saying that like over time it would just become, it's just like a big corporation.
Yeah, exactly. Yeah. Okay. Any other questions? All right. If we don't have any questions, I'll let Alex take over. He's our guest speaker today. Again, Alex from Shima Capital, one of the leading investment firms in the Web3 space. So Alex, do you want to share screen?
Yeah, sure.
All right. Yeah. I'll give you permission to share. Okay.
Okay, how do I make this slideshow? Okay. Okay, hello everyone. My name is Alex Lin. I am at Shima Capital, and first and foremost, thank you for having me, Jack and Mike. So I don't really know if this is the topic I want to talk about. I kind of just put together some slides to kind of get an idea, or particularly, have a directional sense of what I wanted to talk about, but it's not really kind of related to smart contracts specifically. But I do want to kind of give you guys a different perspective on how I view things from my role as an investor in the Web3 space. So before we kind of get into that though, I'll just level set and kind of give you guys kind of my background and how I got to where I am, because I think that's particularly relevant given the state of the industry. So, so Bitcoin, obviously, white paper was written by Satoshi Nakamoto in 2008. Kind of starts us off here, right? And then in 2011, you can see that it's at $1 to $30. It kind of fluctuates between that price year round. And at this time, I actually matriculate to Virginia Military Institute, where I did my undergrad, studied applied math, computer science, and economics. So I was a big gamer growing up. So I actually botted RuneScape accounts while I was in college. And so what that really means is I automated a ton of accounts, leveled them up, and sold them to people around the world. And at this time, you can see that Bitcoin's price is now fluctuating between $13 and $1,100. I mentioned this, right, because this is my first introduction to crypto back in 2013. So Mt. Gox, if you guys, anyone familiar with Mt. Gox? Ever heard of it? Yeah, so it's one of the earliest exchanges of crypto. So you're able to, similar to Coinbase, similar to Kraken, Binance, FTX, you're able to purchase crypto in a centralized manner. And this was actually founded in Japan back in 2010, I believe. And so super early, and that was how I got introduced, right? Because I had a few buyers in Japan who wouldn't want to pay me in USD via PayPal or some of the other means. And so they would pay me in Bitcoin. And I remember at the time, I was like, what the fuck is this digital money called Bitcoin? But it was like 20 bucks at the time. So I was like, okay, it's whatever. So I sold a bunch of accounts for Bitcoin. 2014, I interned at Dell. And I was a firmware engineer there. And while I was there, Dell actually started accepting Bitcoin for purchases. So you can see here that they used a product, which you guys are probably all familiar with, called Coinbase. And at the time, the enterprise product was called Coinbase Commerce. And so I would go on Coinbase, and I can, with all the Bitcoin that I made from selling RuneScape accounts, could buy an XPS computer at Dell. So this is 2014, right? So this is 8 years ago, and $200 to $400 Bitcoin fluctuating. And so at the time, I thought I was like, this is going mainstream, right? Everyone can now purchase everyday items using Bitcoin. This is crazy. And so that's when I really started getting into the tech and whatnot. And then I graduated in 2015, actually started my career off as a consultant in Deloitte's S&O group. And you can see things are starting to pick up, particularly on the enterprise level. Deloitte, their auditing firm or auditing group starts exploring kind of blockchain tech. They started a blockchain group at Deloitte in 2015, which I actually tried to join in SF. I was based in DC at the time, and bureaucracy at a large corporate firm happened, and I couldn't go. They wouldn't let me. The DC partners wouldn't let me. And I ended up leaving Deloitte rather soon after. Bitcoin's still at $200 to $400, and now Ethereum enters the scene. So you guys talked about Ethereum today. Ethereum started by Gavin Wood and Vitalik. In less than $1, right? So I think it's at like 2,000 now. So then across the last, the last 5 years, 6 years or so, I actually jumped into the startup world after Deloitte. Was an engineer and product manager at 3 startups, including Tether Health, which I started. Teads is an ad tech company that kind of put ads onto websites. We were acquired in 2017 by Altice, a Dutch telecom company. Conservative is an enterprise SaaS company that I led product at, which was acquired in 2020 by a private equity firm called Long Arc Capital. And then I started Tether Health kind of around 2020 to help people recover from musculoskeletal pain and injury. So kind of like a ZocDoc Mayo Clinic competitor. And then while I was doing that, I decided to go back to grad school at Cornell and Cornell Tech, focused on computer engineering and then getting an MBA. And that was kind of when I decided I wanted to switch full-time into crypto on the investing side, given my background as an operator. And so I was a venture partner at a firm called Old Fashioned Research, which is a fund started by former Binance executives, Binance being the largest exchange in the world. Did a few deals for them, which is how I got connected with Shima Capital, which I'll talk to you guys in a second. But Shima Capital, I joined beginning of this year as I wrapped up my grad school January. And so I've been there for the last 8-9 months or so. And I am now leading the research team and on the investment team at Shima. So that's kind of my background to level set. And we can kind of jump into things, right? So Shima Capital, where I am now, is an early stage crypto native venture fund. So we only invest in crypto companies. All the logos here are is really our investor network. Some of them are LPs, a lot of big names here, a lot of crypto native firms here as well, right? We have Paradigm, Hashed, Defiance Capital, for instance. And this was all started by my GP, Ida Gao. He launched Shima Capital last year, kind of around May. And we invested in Mike and Jack's company, Eastside, which is why I'm here today. But yeah, so we only focus on crypto native companies, pre-seed seed. And so when it comes to a fund in crypto, it's particularly different from your traditional VC funds. Why is that? Because, well, one, right, I wouldn't say we're early. I think, 2008 is after, what is that? 12 years from now, or I guess 14 years now. It's been a while. I would say we're still young though. And so what that means is there's a lot of necessities that founders need in the space. And so being in the space for so long, we've decided that we really need to focus on 4 core areas for our founders that we're backing. First one being marketing. So we have an in-house marketing team to help amplify the narrative of our portfolio companies, right? Really connect with users such as yourselves, because crypto right now is still so retail driven. It's not very enterprise yet. Talent. So we have an in-house talent team to help recruit talent, right? Obviously, what you guys are doing with learning Solidity, there's very few of you out there. And so if you think about all the applications that need to be built in the space, talent, especially engineering talent, is rather scarce. And so we help our portfolio companies find those people across not just engineering, but products, marketing, et cetera. Business development, right? So a lot of, when it comes to starting a company, you need to work with a ton of third parties. You need to work with other portfolio companies in an investment firm. You also need future fundraising, right? So we, if I go back, you can see all of our network from our LPs and investor network. And so we make those introductions. And then lastly, research, which I really focus on, and technical advisory. We get behind a whiteboard, right, for our portfolio companies, and we help them design their token. We help them design their architecture. We help them improve their product. And that's really kind of where we roll up our sleeves and get down and dirty with kind of, building out the company with the founders. So this brings me to kind of, I guess, something that I want to focus on and give you guys some more perspective on right today, which is what are we investing in? There's so much stuff going on in this space, and you can kind of see how we're breaking it down. First one, so actually just overall, right? So first starts with consumer, gaming and metaverse, composable financial systems, decentralized infrastructure, and next generation blockchain technology. So I'll probably come back to this slide a few times, but I want to give you guys kind of a sense of just general landscape of how things are broken up. So if you think about some of the things that you guys talked about today, right? EVM, Ethereum. So Ethereum in and of itself is its own ecosystem. And so you can see here, we're classifying it as a second gen layer 1 network. Have you guys covered layer 1, layer 2 stuff yet?
No, not.
Okay, so
briefly talked about it in the previous.
Yeah, okay, cool. So layer 1 is kind of the base layer, right? So that's where your settlement happens. That's where your consensus happens, in which you settle, the decision of a transaction. You have all of these. So you see on the first or on the far left, you have Bitcoin, right, dating back to 2008. And really, it's not, because Bitcoin didn't have smart contracts when it was first created. Even though now the smart contract layer, Lightning, as we talked about, stacks, I'm still categorizing those in first gen. Second gen, Ethereum, BNB chain, which is Binance's layer 1, Tron, Hedera. That comprises of a majority of where people are building, right? That's why you're learning Solidity. So when you want to create your own application to be built on a network, it's going on Ethereum because that's what Solidity's application language is. And then you can see third gen is kind of where all the hype since 2017 has happened. 2017, 2018, 2019, obviously a bull cycle into a bear, and then now back to a bull, and then now we're in a bear again. You can see, this is just a handful, probably the top, 20 or so, or 15, however many there are, of the top third gen layer ones in which people are building, and there's a ton of money and liquidity going in. And then lastly, we have fourth gen, which someone mentioned Move in here earlier. So Move is the programming language for these two fourth gen blockchains, Aptos and Sweet, both which are spun out of Diem, which is Facebook's former blockchain layer 1. Zuckerberg shut down that program. The teams and the people behind Diem are incredibly smart, and they split up. So Aptos is effectively the replica of Diem, right? So they're trying to just build Diem but on their own, right, without Facebook. And then Sui is actually the research team of Diem. So if you think about the R&D team of Diem, like I guess more big brain, more giga brain, more focused on more innovative stuff. And so they're actually doing something super innovative, which is building something called the PBFT, probabilistic Byzantine fault tolerance consensus mixed with the DAG, which stands for directed acyclic graph. And so that's a super hyper efficient blockchain. Maybe you guys will cover that, some of what I just said later. But what that does is it effectively makes you able to build any type of application at scale, right? Because gas costs are obviously a big problem with Ethereum. It reduces gas costs while maintaining high levels of security. So all of that's possible with the Move language, which we talked about earlier. So hopefully that answers someone's question, so it's separate from Solidity. So I mentioned this, right, because this serves as the underlying layer in the ecosystem in which everything that we invest in matters. So, so what does that mean, right? So taking another step back, this is an OSI model. The OSI model is a good way for us to really understand how the internet, Web 1 and Web 2, is comprised. So application layer, think all of your applications, right? Think Facebook, think Google, right? Everything that you interact with as a human at the top level. And then underneath, there are 6 other layers that actually make your interaction with the application possible. I'm not going to go through all of them, but this is important to think about because at each layer, for us, it's an investable opportunity. So, yes, question.
Back to the last slide with all the liquid tokens or like
Yes.
Tingo, you guys aren't necessarily investing in purchasing up those tokens. You're investing in the company that you're helping them develop the token.
Great question. So, and please ask questions whenever. Great question. So we are not investing necessarily in the layer ones themselves. I would say a majority of our investments are illiquid, which means we're investing in the company. And the company itself will eventually release a token, right, to represent equity, right? Just think of tokens as equity, but with the utility function. So they will eventually our investments will eventually release a token, but they are not layer ones. Now, the reason we don't invest in layer ones is because these valuations are too fucking high. Like Aptos raised their first round. I think they raised $300 million at a $4 billion valuation. And if you think about economics as an investor, right, you would need, if we put in $1 million at a $4 billion valuation, we would need the market cap for that company for us to get a $100 million return to 100x. So they would need a $400 billion market cap, which is Apple, right? So you don't make those bets, especially in our stage, unless you've invested in size, and we don't have size. We're a $200 million early stage fund. versus SoftBank. I mean, they're dead now because they suck with investments. Wait, just kidding. This is recorded. SoftBank's great. They made some poor investment decisions, unfortunately. No, but yeah, so SoftBank can invest with size. For instance, Tiger Global, a lot of our investors, Bill Ackman, they put in $50 million and it makes more sense for them, right? Because all it needs to do is 5x and they make, 250 million.
So what's your standard like check size then?
Yeah, so we write $1 to $2 million check size in projects, hopefully lower valuations, right? Because we're more price sensitive. And depending on the round, if the valuation is only $10 million and so they're only raising 500,000, we'll write a $500,000 check.
What's the got you the most about Jack's company?
Oh, that's a great question. Actually, I have a slide on that. I want to talk. We can talk about each side. There's so much stuff. Okay, yeah, each side. I mean, this is the only side. It's the logo. So yeah, eSign is an application, right? And so we're gonna jump around a little bit. So eSign is an application built on
It's in the name.
Ethereum. Okay, great. So they sit at the application layer level because that means all of us can interact with it because it acts like a DocuSign, right? So you can sign transactions and it's decentralized. It makes it really unique. It's a really interesting value proposition. And I would say, you asked, the reason we really wanted to invest in this company, and honestly, I didn't lead this deal, Ida, our GP did, but from what I am aware, if I were to go back in time and make this investment, it's predominantly focused on this bridge between Web 2 and Web 3. So I would actually classify eSign to start off, correct me if I'm wrong, as a Web 2.5 company, as an opportunity. So it sits between Web 2 and Web 3 because there are some primitives that eSign is built upon that taps into Web 2, which is this idea of signing documents digitally, right? That's not a Web 3 thing. But a lot of the mechanisms to enable that to happen, to separate itself from Web 2 primitives, that DocuSign, right, the Web 2 equivalent, it makes it an incredible opportunity. Decentralizing electronic signatures opens up a whole array of opportunity for signing legal contracts, tenders, right, NFTs, everything. And so digital identities. And so now you get, so really what it comes down to is product, right? The upside is there, the market's there, and then the team is very strong.
Appreciate it.
So when you were saying about like what you're looking for investing, you're talking about like early stages, almost like equity, right?
Yeah.
Are you guys not concerned about like regulations in terms of some of these projects later down the road being classified as securities and then them having to pay fines?
Yeah, so yeah, good question. So we are concerned with that. We're constantly keeping tabs on the state of regulation and whether the tokens will be classified as securities and whatnot in the US and really every country, but the US predominantly. The way that right now, as we structure our deals, when you make an investment in a company in just the regular world, traditional VC, mostly in pre-seed, early stage, before you actually get equity, you sign something called a SAFE, so a simplified agreement for equity, which is something that Y Combinator came up with, and everyone kind of follows that structure. So we actually sign a SAFE, so we actually want equity in the company, with the assumption that they won't ever launch a token, or they don't ever launch a token because regulation happens. And what we also do on top of that SAFE is we sign something called a token warrant or token side letter, which says when you guys eventually do launch a token, right? Because we hope they do, and let's just assume regulation isn't involved or isn't gonna limit that from happening. That means we can take our equity that we invested in, so $1 million worth of equity, and we can convert that to tokens.
So it's almost like a new type of convertible.
So it's a new type of convertible note. Yes, that is correct. And so, so that is how most deals are structured with funds such as ours, where we will get both exposure to their equity. So if they get acquired, we will get, we will win, and then if they are valued well. And then if they launch a token and the token goes to the moon, then we also win, right?
So, sorry, what price would, is the deal with the tokens? Like you say, oh, okay, when your token launches at this price, you will get that.
Yeah, so you set the token price.
Okay.
So a lot of times, because we're so early, pre-seed seed, that we work with our companies to decide that. So, you know, when we invest, it's some fair value price that we, that, you know, when you think about, I mean, this is getting into like tokenomics and tokenomic design, but, you know, there's different ways to set prices for what your token should and shouldn't be based off of supply and demand of your products and utility and value, right? So if you think about Uniswap governance token or like Yearn, some of these applications that launched a token, now their tokens are worth thousands of dollars. You know, it started off in the sense because in their minds, right? You know, eventually they want to get to that point, but it's all based off of the economics of how the token will increase, decrease based off of supply and demand.
Do you invest in companies before they have products?
Oh yeah. Yeah, we do.
So
So it's a huge risk, but it's a huge risk. And by the time they do have an MVP, right, like valuations are way too high. That's just been kind of the nature of the beast. And so you just have to take a bet on the founder. You have to take a bet on, you know, their vision, and then work with them so that they actually get product market fit.
so it's almost always before that.
And MVP, not necessarily. Sometimes they'll have a product, and we just got lucky and found them before other investors did.
I kind of had a follow-up question to my last question. So I'm assuming that a lot of these Web3 firms like yours do the same thing, right? But for the token thing.
Oh yeah. Well, so not really. I mean, it's hard. Token design is hard. So like, so we actually work with token design firms as well. So like for public crypto, Republic is also an app where you can invest in companies, and so they have an arm focused on token design. Economic Designs is another one. Prism Group is another one. So yeah, there are token design firms that we work with, and we also do it internally to advise our portfolio companies. But not all firms have that feature or that utility and value add.
Okay. My question is like, say enough of these firms have this way of making the deal. Do you think that's going to affect, say, when the token is made and the first, I don't know, X number of tokens go to VCs, because assuming that they're going to raise a few rounds,
Yeah.
do you think that's going to affect the economy in a negative way?
Yes. So, you know, there are some investors that dump tokens. So as soon as the token launches, they'll sell. And then, you know, when you sell your tokens, that obviously decreases the price of the value of the tokens. That happens all the time.
Yeah.
It's inevitable, but that's why there are, you know, let me see if I can token. What's something I can show you guys? I don't think I can show you guys anything. But yeah, there are like token, actually, no, I can show you this.
Has any company like asked
So, like-
to have that as a safeguard beforehand?
Yeah, okay, so you can see here, right? So like you can see like certain values. Actually probably shouldn't be showing this, but it's fine. But like you can see distribution percentages and then the supply of the tokens that they get and then the conditions in which they're aligned.
Cut out this part of it.
That's okay, that's fine. I assume none of you guys know what deal that was. So yeah, and I think that like those are all set, and like usually the expectation of the founder and the founding team has a general idea, right? They're crypto native, and when you make the investment, they have an understanding of what they're getting themselves into.
I was gonna ask like how much of your firm's operations is like researching the companies and like actually investing in the companies, and like versus how much you're working on like actually working with them and like advising them, and how involved you're there.
Yeah, I would say that for during the bull market, so the last, you know, all of 2021 into around March, April this year, it was very much heavy on like the investing, because like, you know, there were a lot of good companies, bull market, everyone's hype, you know, everyone's valuation. I mean, it should be the other way around, where you're not investing as much because valuations are so high. But it ended up being that way. And so I spent, you know, 90% of my time just doing like diligence on deals and investing in deals. And then now in more of a bear cycle, there is a particular focus on our portfolio companies. I would say, not because, we want them to succeed, we want them to get through the cycle, and so we do everything that we can. And also deals have slowed down, so it's kind of this like natural evolution of how cycles kind of play into the behavior of companies that are being built and quality of companies. I actually wrote an essay on this, if you guys want to check it out. It's on our website, it's under our research tab, but yeah, I would say the breakdown fluctuates depending on the cycle. Also depends on our portfolio companies, right? Not all of our portfolio companies require help all at once, and so we'll definitely be assisting them where they need it. And so yeah, it really depends. So anywhere between 10% of our time all the way to 90% of our time. Okay.
Cool. I need to run to the next class.
Okay, yeah.
Yeah.
Well, hopefully this gives you guys an understanding of venture in the space. And then, yeah, if you guys have any questions, just let me know.
Alright, guys, homework 1, next Tuesday now, and get it done, yeah? Otherwise, have a good weekend.
Yeah. How do you enjoy investing and advising?
So yeah, it's different.
And do you think you'll do like so long?
So I did, but I never, institutional investing is very different.
Yeah.
Alex
So-
speaking tonight.
Yes. We have a better panel after.
Yeah.
What time is it?
7 o'clock, GFS. Blockchain at USC.
I'm gonna be here.